Welcome, my name is Patrik Rugeland from Ericsson, and I'm the technical manager in the Hexa-X project. Today I will present our first results from our deliverable, covering the 6G use cases and key value indicators. To begin with, we'll present our vision on the use cases for 2030. So in the Hexa-X project, we have identified many different potential use cases for 2030. And to organize them, we've grouped them into 5 separate groups. The first one we call sustainable development, looking at how 6G can help build a sustainable world. The next one is massive twinning, looking at different examples how digital representation can be used in different parts of society and industry. The next one we call telepresence, looking at how you can experience the world remotely with all of your senses, being virtually or using merged reality. The next one is the robots to cobots, looking at how the evolution of AI and autonomous systems will be more ingrained in our society and handling more complex tasks. And finally, local trust zones, where in many cases there is a need for guaranteed high performance, either in throughput or reliability or security, where the wide area networks cannot provide this, and you would need a local area to handle this. For each of these use case families, I will present one representative use case, showcasing some of the key aspects. The first use case we call e-health for all within the sustainable development use case family. And the idea here is to provide affordable healthcare to everyone, both in rural and remote areas, as well as underprivileged areas in affluent areas. Of course, in affluent areas, we can provide even more advanced healthcare using advanced end-user devices. But even in rural and remote areas, AI and XR can help health workers provide better healthcare. And finally, with this virtual healthcare, public health monitoring can be provided, for instance, for disease prevention. For massive twinning, we look at the example of immersive smart city. And here the idea is to take the concept of the digital twin, popularized in 5G, and take it to the next level. We envision that you take a whole city represented as an accurate, real-time, 4-dimensional map where ubiquitous sensors and actuators enable accurate planning and management and forecasting of all relevant aspects in cities. This includes utilities, public transportation, healthcare and monitoring, and environmental and pollution monitoring. For the telepresence, we look at a fully merged cyber-physical world. And the idea is to bring the virtual and augmented reality to the next level. What is currently being discussed in 3GPP with XR will be very prominent in the coming decades. And you will be able to experience the merged reality with all of your senses, blurring the line between the physical and the digital world. This could be, for instance, be meeting your friends or colleagues remotely as if you were there, or interact with physical or virtual objects with remote colleagues. For the robots to cobots, we will be looking at the interacting and cooperating mobile robots, where we will have a massive number of autonomous robots and systems which will self-organize to collaborate to solve simple and complex tasks. With these new type of communication, we'll set new type of requirements on the systems, for instance, in reliability, functional safety, latency, and position accuracy, which will be different compared to when the human is in the loop. And finally, we have the use case family local trust zones, where we'll be looking at dynamic and trusted local connectivity. And as I mentioned earlier, some applications may require a temporary solution with very high performance and reliability and security, which a wide area network cannot provide. Could, for instance, be a body area network in personalized healthcare during a surgery, or a harvesting campaign where the equipment are collaborating, or the cameras, microphones, and broadcasting equipment in a program making or special event. Of course, a special solution can be used here to provide this already today. But to reduce the cost and increase the automation, this will require, for instance, self-adaptive networks using relays, mesh, or device-to-device communication. And to provide a performance, local spectrum usage with spectrum sharing or automated licensings would be beneficial. In addition to these use case families, the project have also identified a number of services based on the new capabilities we envision for 6G that are not directly applicable to the end user, but will help with the other use cases. So the first one we call compute as a service, where we have edge cloud computing everywhere in the network, which will enable flexible compute resources available to end user devices and network nodes everywhere, so that the operators does not need to provision for the peak load. And this will also enable to offload computations from lightweight devices. By leveraging on the edge cloud, the network can deploy and instantiate artificial intelligent agents everywhere and provide AI as a service. These agents could either be used to manage and optimize the network or be provided to end users for artificial AI applications. And the customer would only be exposed to a GUI and a number of APIs, while everything else is hidden and handled by the operator. As a specific use case of the AI as a service, the AI-assisted V2X will be employed to assist automated driving as well as real-time traffic flow management, for instance, to minimize congestion. In 5G, we can already provide predictions where the connectivity will fail, but in 6G, this will be more accurate and with a flexible time window, and it will be easier to add new KPIs to monitor and provide information to the vehicles or infrastructure. The next enabling service is called flexible device type change, where we have logical device types that flexibly switch their requirements depending on which task they will be handling. For instance, you have an industrial robot that switches between high-precision tasks of welding, for instance, requiring sub-millimeter precision and sub-millisecond latencies. But then when it's switched to another area of the factory, the movement will not require such precision or latencies. Then it can switch device type. Or when it's stationary, it will not require very high requirements at all. For instance, only requiring high throughput for uploading or downloading information. So the next use case service we call the energy optimized services. And in order to cater to environmentally friendly users, then operators can offer trade-off between performance, cost, and environmental impact to ensure that the total end-to-end energy consumption and environmental impact are minimized while still providing an acceptable service level. The next service we call the Internet of Tags, where we envision that many different types of devices will be present everywhere, providing very simple services such as tracking or sensing. And this could, for instance, be RFID tags or simple connectivity devices. And in order to reduce the cost, these would preferably be printed electronics. And to avoid the need for batteries, these will need to be self-powered, for instance, using RF energy harvesting or using solar power or mechanical energy harvesting. Finally, as 6G is envisioned to expand the network deployment flexibility, there will be an increased need to be able to verify the security and authenticate all entities in the network path. To facilitate this, attestation procedures for the infrastructure, functions, topologies must be developed and to enable assessment of the end-to-end security. Thus, there is an opportunity for operators to deliver network-based security services that remove the complexity of securing connected devices at home and on the go. So if you look at how these services can be used in different representative use cases, we'll see that for the computer as a service, the AI as a service, and the energy optimized services are beneficial for all use cases. On the other hand, the flexible device type change would also be beneficial for the interacting and cooperating robots, whereas the security as a service is applicable to the trusted local connectivity. If you look at the use case immersive smart city, we see that the applications are so diverse that all the enabling services are useful. Moving on, we will look at how the performance indicators will look like for 6G. And to avoid the race for a sticker price performance of 6G being only X times 5G, we're looking to broadening the KPI concept and also looking at what we call the key value indicators. So looking at these KPIs, we will take both a top-down approach, looking at what the use cases require, as well as a bottoms-up approach, looking at what technologies are capable of. From this, we will be looking at several KPIs, which we've extended and grouped into several different areas. So the first one is simply expanding the existing KPIs, increasing the throughput, the density and capacity of networks, as well as localization accuracy to serve the use cases of 2030. However, several existing KPIs would need to be extended to be looking at more end-to-end perspective. For instance, it will not suffice to simply reduce the air interface latencies if the rest of the network cannot guarantee a low latency for the application. Also, for the energy efficiency, we need to look at the entire ecosystem and not just looking at the spectral efficiency. And for coverage, in order to ensure truly global coverage, we can't just look at the link budgets. Next, we have a few new aspects related to new capabilities that we envision for 6G. For instance, integrated sensing, compute, and artificial intelligence, as well as embedded zero-energy devices. For each of these capabilities, it is expected to contribute to achieve the other KPIs, such as using sensing to achieve better beamforming, or using local compute to reduce latencies, or using AI to improve the performance. However, they will also introduce new domain-specific KPIs, such as sensing accuracy, compute round-trip time, or AI model explainability. And finally, we see a few different areas associated with the Hexa-X key values, the sustainability, trustworthiness, and inclusiveness. And we can see that the sustainability consists of two parts. Sustainable 6G, taking into account how to minimize the environmental impact of the 6G systems, and 6G for sustainability, looking at how 6G can enable other sectors to increase their sustainability. In addition, we foresee that the 6G systems will offer tremendous flexibility, both in terms of deployment and operation, but also in terms of service and infrastructure provisioning. Each of these KVI areas is multifaceted and in themselves encompass many different perspectives. And each of these perspectives need to be associated with a key value indicator, which will be different for different use cases. And since KVI is a new concept within mobile communications development and reflect that technology need to be considered from socio-technical aspects. And as there are many competing and counteracting indicators, it will be important to balance all these while maintaining an acceptable total cost of operation. So, looking at how these KVIs can be defined and evaluated, we start with the project vision with the key values inclusion, trustworthiness, and sustainability, and the vision of connecting the three worlds, the physical, digital, and human world. And an extension of this are the research challenges of what need to be addressed by the project. First, we have the ones related to the key values, trustworthiness, global service coverage, and sustainability that need to be addressed. But we also have the more technical challenges, extreme experience, connecting intelligence, and network of networks, which will require novel technical solutions. Based on this, we have defined the use cases that I showed earlier. And if we look at how these different use cases can address the United Nations Sustainable Development Targets, as well as other more traditional ICT targets, such as entertainment or ease of life. From these targets, we will try to define some value indicators in order to be able to quantify these results. And finally, we will try to map these value indicators onto more traditional performance indicators. As an example, if you have an autonomous robot in an area full of humans, in order for it to be trustworthy, you want it to have very few accidents. And to achieve this, you need very accurate localization and sensing capabilities, and very short response time in order to stop it if something unexpected happens. As another example, we can look at how the sustainability relates to the KVIs. In the project, we have started from the UN Sustainable Development Goals, where the UN have defined 17 separate goals. For each of these goals, they have defined a number of so-called targets, in total 165 of them, to see how these goals can be achieved. And for each of these targets, they have defined one or more measurable indicators to be able to quantify the progress. If we look at 6G, we see that the sector is linked and interacts with all 17 goals to some extent, where some targets are applicable while others are not. However, these 231 indicators are typically not directly applicable to 6G, but are rather more on a national government level. So we are analyzing different use cases at a target level, but then develop our own indicators. For instance, for the goal number 9, the industry, innovation and infrastructure goal, 6G can help ensure digital inclusion by providing universal access to information and communication technologies, and to develop sustainable, resilient and inclusive infrastructure. Or for goal 11, the sustainable cities and communities, where 6G can enable innovative solutions for city management in order to, for instance, reduce adverse effects of natural disasters and to provide affordable and sustainable transport systems. And we can look at target 13, the climate action, where 6G can be used to help monitor and reduce carbon emission, as well as strengthen the resilience against natural disasters. In addition, 6G will be able to enable many other sectors of society and industry to reduce their own emissions. But at the same time, it's important to note that 6G will also have its own carbon footprint, pushed further by the increased traffic demands, which should be minimized whenever possible. So as you can see, the 6G research has only just begun, but we have very exciting times ahead. So thank you all for your attention and hope to see you soon.